We're in section 5.3, Troubleshooting Series Parallel Circuits. Because of the complexity of series parallel circuits, troubleshooting them may be quite challenging. The same rules apply as before with regard to measurements and tools. I won't review them again. Those techniques and troubleshooting charts used for series and parallel circuits individually should be combined for series parallel circuits. And so here we have a circuit that is a combination of series and parallel. And what I want to do is just to walk through some of the things that I might do if I was going to be troubleshooting this circuit. Now, the first thing that I'll note is that there are 5 test points in this circuit. And what we had mentioned in previous lessons is that doing lots of measurements doesn't mean a whole lot unless I have some idea of what I should be measuring. Now, if we look at this circuit, we can make a couple quick deductions. Test point 1, if I'm measuring in respect to ground, this should be 20 volts. If I'm looking at test point 5, in respect to ground, that should be 0 volts. And those are kind of givens. But what we'll see at 2, 3, and 4, we're going to have to do a little bit of thinking, and we can actually quite quickly get an idea of what those values should be. So in a parallel circuit, remember we had our rules that said that in a parallel circuit the resistance of the parallel resistance will be slightly smaller than the smallest component. So I'm going to look at this, and I notice that 500 over here, I'm going to make a guesstimation, and this is just going to be a kind of a guess. I'm going to say about 400 ohms. And oftentimes when you're troubleshooting, your calculations don't have to be, sometimes they'll need to be exacting, but they don't always have to be exact. And then down here in R5 and R6, I know that if you had 200 and 200, the parallel resistance is going to be about 100. Not about, but it will be 100 ohms. So in looking at this circuit, I can see I've got 100 ohms here, 400 here, and then the parallel here, this would be about 400, and this would be about 100. So I can see that I have about 500 here and about 500 here. Now, given that, since I have 20 volts applied and I've got half my resistance is here, my guesstimation is that this would, test point 3 should be about 10 volts because it is half and half. Now down on this side, I'm going to note that, let's see, 100 to 400, okay, that's about 1/5 of this 10 volt. So my guess is that test point 4 should be about 2 volts. And up here, the other extreme, let's see, this is about 4/5. You have about 500 ohms here, so about 4/5 of 500 would be given 10 volts. I would guess about 8 plus, this should be about 18 volts. And so these are some guesstimates about what I would expect to see here. Now, I want to do a quick look at a few faults that could occur here. First of all, let's look at if R1 shorted. So if we had a short, went from R1 across R1, one of the things that we would, and there's a number of things that we could note, there would be increased current in the circuit, so all the drops across every component would slightly increase a little bit just because there's less resistance in the overall circuit now. But as a troubleshooter, if I looked at test point 1, I'd see 20 volts. And since there's a short directly across here, now at test point 2, I would read the same voltage. Now there should be about a 2 volt difference. Now there is 0 volts difference. So that tells me something that this component is shorted. Okay, R4. If R4 was shorted, now let's pretend that this part of the circuit's okay. We'll open that short. And now we're going to short R4. Now in this case, again, if the test point 3 and test point 4 would be the same voltage, whereas before they should have been 8 volts. Or that would be one indicator. Another indicator would be that if we went in and measured test point 3, we would find that it would be quite a bit less than it used to be, because now the total resistance of this circuit is, let's see, there's 500 ohms up here, and there's only 100 ohms down here. So 1/6 of this 20 volts, I should now see at test point 3 vice 1/2 of it. So that would be an indicator, R4, but TP3 and TP4 having the same value would be the biggest indicator. So let's we'll put this back. We'll say this is not shorted anymore. So R6 open. Let's see where. Okay, R6 is down here. If R6 were to open, then the resistance across from between test point 4 and 5 was 100. It would jump up to 200. So now we would see a increase in the voltage at TP4. We would also see an increase in the voltage at TP3, because there was just 500 ohms of resistance between these two. Now there was 600, there's 500 here, so we would expect this voltage to go up. So those would be some of the indicators. I guess I would probably be concerned about this test point 4 having the increase, because that would be a substantial increase at that point, and then I would need to go in and measure resistance and probably observe that this usually when they open is because they overheated and they might be burnt, they might even smell. So anyway, R6. And then R4 being open. Now in this case, if R4 were open, if we had a voltmeter and we went in here, and usually you're measuring voltage in respect to ground, and if I measured the voltage at this point, I would see the supply voltage, and that would be the giveaway that I have an open circuit, is because I'm measuring the supply voltage at at a midpoint in the circuit. If I was to measure the voltage across any of these components, I would find that it would be 0, because there is no current flowing in this circuit at this point. Also, I might mention that if I measured this side of the component, I would see the supply voltage. But if I had, let's say I measured from here to here, now I'm measuring from ground to the bottom side, I would measure 0 volts. So this is some of the thinking that a technician might go through in troubleshooting a parallel or series parallel circuit. These are a lot of fun. It's kind of an exercise in applied physics to see how are circuit parameters changing when given components either open and or short. So this has been a quick look at troubleshooting series parallel circuits.